video about how to use your calculator to do some calculations with limits, do some limit calculations. So let's just take a look at this very first problem. We're going to find the limit as x approaches 3 of x squared minus 9 over x minus 3. So this is just a straight limit. It's not the slope of a tangent line, it's just a limit. So the way we do this is we go into our calculator, we go into the y equals window, and we type this equation in. Because it's a fraction, we need to put parentheses around the numerator and the denominator, okay? So x squared minus 9, that's my numerator, divided by numerator, or denominator, x minus 3. Okay, I've typed that in. Now I'm going to want to use the table, and to make sure my table is set up, I need to go into table set and make sure that under independent it says ask. Then I'll go second graph, that takes me to table, and here I will be able to plug some numbers in. Now I want to pick numbers that are close to 3 because I'm looking for my limit as x approaches 3. I'll start with a number that's a little less, maybe 2.9, and I see I get 5.9. What happens if I get a little closer? It looks like I'm getting closer to being 6. What happens if I try something a little bit bigger? I get something a little bit bigger than 6. What if it's a little closer to 3? I get closer to 6. I wonder if I plug in 3, will I get exactly 6? I don't. I get error. That's okay. I should have known that. 3 minus 3 is 0, and so the denominator of this expression would be 0, and so I can't plug in 3. But the limit does exist, and it is clearly here equal to 6. Okay? So this limit is equal to 6. We can see that because the numbers that we plug in that are very close to 3 give us numbers that are close to 6, and the closer we get to 3, the closer the outputs get to being 6. All right, let's take a look at another problem now. Find the slope of the tangent line to f of x equals square root of 6x minus 2 at x equals 1. That's a fairly complicated problem, but we're just going to go through it step by step and be able to do that using our calculator. The first thing we need to do is find out what f of 1 is. So f of 1 is the square root of 6 times 1 minus 2, which is the square root of 4, which is 2. So we're interested in finding the equation of the slope of a secant line that connects 1, 2 to another point on the graph. So another point on the graph is going to have x-coordinate x and y-coordinate square root of 6x minus 2. So we use that fact and the fact that we know we want the point 1, 2 to create an equation for slope. And then what we're going to do is find the limit as x approaches 1 of that equation. So let's go back to our calculator, go into y equals, clear out what we had before, and put in this equation for slope that we created. So second, put the square root thing in here, 6x minus 2, except I need to put that parentheses first. I forgot to put the parentheses, so I'm going to say second del. That gives me insert, allows me to put in something. So because we're having a fraction here, I got to make sure I put my parentheses in, minus 2 and parentheses divided by, start my parentheses, x minus 1. That's the equation I'm looking to take the limit of in this case. That's that slope equation. So now I can go back into my table, and these aren't the numbers I'm really interested in. These are numbers near 3. I want numbers near 1. It's okay. I'll just type over them. Let's pick a number slightly less than 1. I got 0.9. If I get closer to 1, I'm seeing I'm getting numbers that are a little bit bigger than 1.5 and getting closer to being 1.5. Let's try 1.0. Well, let's try 1.1. And it's another number that's close to 1.5. Will I get closer? If I get closer, I got closer to being point. What if I get very close? It's saying you're very, very, very close to 1.5. What if I just plug in regular old 1? Again, I get that error. Okay, that's a very common thing with a limit. So the slope of the tangent line in this case is 1.5. Now I'm going to show you a more complicated way to do this by using the function notation on the calculator. So let's go back in here, and I'm going to clear this out, and I'm going to just plug in the regular function that I was interested in, the thing right at the top, the square root of 6x minus 2. So I'm going to type that in, square root 6x minus 2. And then I'll use the function notation that's on my calculator. I'm going to do that slope calculation again, so it's going to be a fraction, so I need to start with my parenthesis, then go vars, y-vars, y1. y1 means the function that's on that first line. And we want to plug in kind of a random point, then subtract from that what we get when we plug in to our function 1, okay, and end that parentheses, okay. I'm going to, again, just show you where I got that y1 from. I hit the vars button. I went over to the y-vars. I hit the enter button for function, and then I hit the enter button again to get y1. That's the only way to do that. Now we'll do divided by, and then the same denominator as before, x minus 1. Then if I go to my table, I'll see all the numbers I had before in the y2 column now. In the y1 column, I'm seeing the value of the function. That's not the slope, that's just the number that comes out of the function. And we already knew that was 2, but here we're seeing the 1.5 that we got before. So that's how you can do a limit, and that's how you can do calculations that will help you find the slope of the tangent line, which is also a limit.